Okay, so in this video, let's understand what information gain is. And so I'll first write the formula for information gain here. The information gain, and then I'll explain it. Okay, the information gain of the class variables given a feature f is as follows: h of y, which is the total entropy of the data set, minus sigma I equals 1 to k d of I by d into the entropy of the particular sub-data set. Okay, so I'll explain what this is. Now, when you construct your decision tree, you need to choose what the root node will be, right? What feature will be at the root node? Because if your decision tree is something like this, you need to choose what feature comes here at the root node. So how do you do that? So the thing is, it's a recursive process where you have to check for which feature gives you the highest value of information gain. So let me explain this with this example. First off, I have four features: humidity, temperature, windy, and outlook, right? So what I do is I first take one feature, outlook, and I divide my data set such that each sub data set has only one value of the feature. Okay, so the first data set will only have sunny, the second data set will only have overcast, and the third data set will only have rainy. Okay, so what this formula sigma I equals 1 to k d I upon d into h d I y says that, so di is basically the number of data points you have in your, the number of data points you have in each data set. Okay, so over here you have, so if I have to write, so this formula, right, if I have to write it for this data set, I'll write it as follows. I'll have 5 by 14 because I have 5 data points over my entire data set, into the entropy of di at y over here. Okay, so this will be like this. It will be, look, I have 3 nodes. Okay, so that'll be 3 by 5 minus 3 by 5 into log of 3 by 5 minus 2 by 5 into log of 2 by 5, right? So this is what the formula is: d by di into h diy. Okay, d by di is the number of data points you have for each sub data set as your response variables, and then you just calculate the entropy of that sub data set. So here I've done for the first data set, the first sub data set. Now I have to add it into the now I have to add the same formula for the second sub data set. Okay, so that'll be 4 upon 14 into 4 by 4 log of 4 by 4 minus 0 log of 0. So this basically turns out to be 0. And then I do the same for the last sub data set, which is 5 by 14. 5 because I have 5 response variables over the total 14 in my sub data set, and multiply it by 2 by 5 minus 2 by 5 log of 2 by 5 minus 3 by 5 log of 3 by 5, right? So if you look, so this is what this formula basically is. Okay, and if you look at it closely, this is basically like a weighted average of the entropy, weighted average of entropy for each feature, right? So my information gain, so if you calculate this, if you just simplify this and you calculate it, you get the value of this entire thing as 0.69. Okay, that's the value that you get. So my information gain for the output or the response variable y given the feature outlook is basically 0.94 minus 0.69. Okay, I got 0.94 from the previous video. Okay, I've explained how I got 0.94 in the video titled entropy. And that's my information gain for the output variable, response variable y given outlook. Okay, so this comes out to be 0.25. Similarly, you have to calculate the information gain for y given every other feature. That is temperature. Okay, you get some value. Then you calculate the information gain for y given humidity. You'll get some value. And then you calculate the information gain of y given windy. Okay, you get some value. Now, you have to choose the value of information gain which is the highest. Okay, basically information gain is like you're gaining some information on what you already know. On the base entropy that you had h of y, you're gaining some information, right? So we want that information gain to be the maximum. And so whatever value of ig, which is information gain, that we get as the maximum, that becomes our root node. Okay, so in this case, in this particular data set, it so happens that Outlook gives the maximal value of information gain. So we choose the value of, so we choose output as our feature in the root node of our decision tree. And then we go on to construct the decision tree in the same way after this. Okay. So now what we do is that, so when we have Outlook in our root node and we divide into three parts, which is overcast, sunny, and rainy. Overcast, sunny, and rainy. So it's easy to see here that overcast basically has only one output variable, which is yes. So overcast is a terminal node or a leaf node. Okay, y equals yes. Overcast is where the decision tree stops. It doesn't go further down from here, but it will go further down from sunny and rainy. So when you build the decision tree from sunny and rainy, again, you have to follow the same process. Now my h of y becomes 0.25. Instead of previously I had 0.94, now it's 0.25. And after this, what I'm going to do is I'm going to again divide my data set into three parts. Okay, no, I'm sorry. This is not h of y is not 0.25. H of y is still h of y is still 0.94, right? And now what I'm going to do is I'm not going to consider outlook as my as one of the features. I'm going to take temperature, humidity, and windy, follow the same process all over again, and see what gives me the highest value of information gain. Okay. So now that I have sunny over here, I'm going to take, let's say I'm going to take temperature, and I'll divide temperature based on hot, mild, and cool, right? And that's how I keep on progressing forward my decision tree. So how do you know where to stop? Well, there are two conditions to building your decision tree on how to stop. All right. The first one is that if you hit a terminal value, okay, like over here in overcast, we hit a terminal value, y equals yes. All the values for overcast give a response value of yes. So that's a terminal value. So that's one place to stop, okay, when you hit a terminal value. The second part is to do something called hyperparameter tuning for the depth of your decision tree. Okay, so you basically say that I will not build my decision tree up beyond a certain depth, and that is where you will stop your decision tree. So that is basically, the depth is basically a hyperparameter in sklearn. Okay, so that's how you go about building your decision tree using information gain.